Okay, everyone. One last lecture. I might do some supplemental lectures, especially if people are getting confused by certain topics. But this is the last lecture I wanted to go over before the end of the course. I know these are a lot to take in. You're not live listening. It can be very distracting. Just a quick reminder, if you are getting distracted, if you're having problems, if you're getting a little confused, watch the videos a little chunk at a time. You don't have to watch it all in one go. You're supposed to pause the video as you go along if we have any exercises to be done, or if you just need time to digest something, or if you want to try something out yourself. I There are 1 hour, fairly dense 1 hour chunks at a time, so try and break them up if you need to. Okay, so we're going to be looking at good programming practices. This is going to come up in assignment number 11. And that assignment is essentially you reviewing each other's code. And so we'll look into that in a bit more, what I mean by that and what set of standards are we going to be using. So I want to illustrate some of the best coding practices that we have, what makes good coding style, code quality, that sort of thing. This, if you end up becoming a programmer later on in your career, this is everywhere, everywhere right now. Um, Anyone that's doing any coding whatsoever, they have some other person on their team that's also coding, and you're supposed to look at each other's code. Very much like if you are writing an English essay or you're writing a novel, you don't just, you have an editor, you have a publisher, you also have peers that can review your work and make suggestions. No one creates in isolation, and this is how programmers check each other's work. Um, so we'll even look at what constitutes a good peer review. Now, most of these things will require a lot of practice. It's extremely easy, much like, trying to clean your room or flossing daily or any number of other things you should be doing. Um, these sorts of things require not only practice, but it's extremely easy to just get lazy. For example, in the last lecture when we were doing file IO, I quick quickly created a file to read in, a bunch of code to be able to read in a particular file. And I'm going to go over that code again. I modified it, but even the original code, if you look at it, pretty terrible. I mean, there is no comments anywhere, and even the wording for certain things is not ideal. After I've done it once, much like, you write your English essay and you look it over, you're like, what was I thinking? What did that sentence even mean? Or why did I write it that way? It takes practice, it takes repetition, and it takes going back over your work again afterwards. So, we're going to go over a whole lot of these good practices or best practices, and I should actually do a full screen here. There we go. We're going to go over each of these in order, and then we'll look at an actual snippet of code afterwards. So, things that we looking at. So, indentation, that is not as big of a deal as it used to be because Visual Studio and pretty much every integrated development environment does the indentation for you. Don't fight it. In the bad old days, you used to put it in by hand, and if you didn't do it right, it looked terrible and no one could read your code. It is one of my biggest pet peeves is bad indentation. So please make sure you indent correctly. Meaningful, useful comments. We'll look at that in more detail. Um, how readable is your code? Can another logical or reasonable human being read it and understand it, especially if they know how to program? Uh, do you have a logical structure to your code? Not just being able to read it, but does it make sense how everything flows? Do you use meaningful variable names, or were they all named A, B, C, and D? Like people will give me that. Um, I'll have a little story about that. Hopefully, if I remember. The KISS keep it simple, stupid principle, which we'll explain later. What makes we sometimes want efficient code. This is actually one of the most critical things for computer scientists when you get into if you're actually coding in any large amount, not just little toy projects, but if you're actually programming something, you are expected to have that part, point number 7, down cold. It is one of the most important things. It is what makes computer science a science. That is one of the big paramount issues. So we are also trying to minimize side effects for our code or special cases. On a Tuesday, don't call this function, otherwise it explodes. We don't want to hard code any values. We'll talk about that. We want to maximize the number of possible inputs to a function. So the more possible legitimate inputs that you can give me, and I want to make certain guarantees about what the input looks like and make that a maximum, and I want to minimize what possible outputs I have for the output. We'll look at that. And then testing. Now I want to hit testing right now because I don't have an extra slide on it. When I'm talking about testing, it doesn't necessarily have to be this formalized testing. Printf statements and just checking to make sure it printed out the right or expected information is a rough form of testing. Putting a breakpoint and looking at what the code looks like, a rough form of testing. What you want to be able to do is make a prediction what your code's going to do and then test that it actually matched that prediction. That way you know if your code, at least in this one particular case, you know that your code is working. The more predictions, the more tests you have, the more likely your code is logically correct. The more likely your code is actually going to do what you say it's going to do. If you think testing is not all that useful, because I've been throwing asserts everywhere in our code, I like pointing out the fact that at Google, so I was working at a computational fluid dynamics company. That's a fancy term for they do physics simulations for fluids. So if you're talking about airflow over an airplane wing or a drone wing, how does that work? How do you make sure that the math is right so that you can model and sort of design a drone or an airplane before you actually manufacture it to make sure that what you expect to see in the simulation should be what you get in the real world. So rather than using a wind tunnel right away, you actually plan it and you have a virtual wind tunnel and then you actually build the item. Okay, so that company did some testing, but not that much. I went over to Google afterwards, a couple of years later, and testing was everywhere. They had little posters in the bathroom, on top of urinals, in bathroom stalls, over the sinks, everywhere, in the kitchen. All of these little posters everywhere telling people how to test their code correctly. Testing was so paramount that it was ubiquitous, or it was everywhere at Google. It is one of those things that they're trying to beat into people's heads how important it is to properly test your code. If you don't think this is important, every time you write any server-side code at Google, more than half of your code that you write is the tests, not the code. You might write 100 lines of code and about 200 to 300 lines of tests. You are testing exhaustively every possible thing you can think of to make sure your code works. A unit test is this is what I expect my code to do. So I have a particular function. If I pass in this input, this is what I expect to get for output. The important thing about a unit test is if someone changes your code, let's say I write this particular function and my friend 2 months later modifies my code. All the tests that I wrote should still work. Every single test, what I expect to get, it should still do that thing. Even if that thing it was doing before was wrong, it should still do that wrong thing. The idea behind a unit test is I don't get what's called a regression. I don't get I make a change to the code base and then everything breaks for everyone afterwards. When I make a new version, where I release a new version of CU Learn, if I release a new version of Google Newsstand or Google News, if there's a new version of any of your apps, if they make a change to the app, it should not ever break anything that was currently working. That's what a unit test is for. They are automated tests that never go out to customers. They are just a battery of tests that hit your functions just to make sure that they work. So we're not actually writing our own unit tests, but asserts work like a poor person's unit test. An assert says, I expect this kind of behavior. Now, an assert is normally for, holy cow, this better not be null, otherwise explode. Holy cow, this value can't be negative, otherwise something terrible happened. Oh my gosh, this cannot be outside of the index bounds, for example. Asserts are normally for really dire conditions. Unit tests are normally a kind of test where I can call my function, say what I predict it to do, and get the results. We've been doing something similar, but not exactly a unit test, with things like printf statements, or things like our comments in our code, where I said, make a comment, say what you'd expect the function to return, and then see what the function returns. That is what a unit test is all about. An integration test is if I have multiple blocks of code, multiple classes when we look at classes, multiple, like with very, very large data sets, with very, very large code bases. I want to be able to make sure that when the two parts, big code parts come together, when I build them together, that things don't break, that they communicate back and forth to each other correctly. That would be an integration test when I integrate two different components. And then usability tests are normally for the front end, the images, the things that you see on the screen. Now, a usability test might be getting literally what we've done in video games, and what I think I did at a newsstand as well. It is, you have a big party of people, you all sit down, and you click random things, or click that button 500 times, click this, click that. Make sure nothing blows up when I'm using the interface itself. I can't automate that thing. I need to actually have people physically clicking things. It's the only solution we have right now for this. So, and there's other types of usability tests. That's an entire, well, that's actually the IMD degree is going to be hitting that a fair bit. Usability tests are making sure your visualization works the way you expect, making sure that people can actually use your system and that the button instructions make sense, making sure that when I click something that it disables and people know that why they're not able to click something. The human factors of testing. So the big one for us right now is just some form of testing to make sure our functions, anything that we write, works as expected. You're expected to do that now, and as you program more, these tests are going to become more and more elaborate. Okay, indentation. So in case you're wondering, I wanted to put the curly braces in there despite the fact I didn't want to reformat all the fonts and everything. Um, the curly brace, I always want to put my curly braces in, not just leave them, not do the one line indentation. But every single time I move in a scope, every time I have something in an if statement, it should be indented. If it's in a for loop, it should be indented. And normally we'll use the tab key, and which is approximately 4 spaces. You're not supposed to ever use the space bar to indent. Use tab. And if it happens to be equal to 4 spaces, you can set that, then that's the right way of doing it. What you want is to have this perfect vertical alignment so that you know what is indented from what. I can even tell you about the Gestalt principles for why we do it this way. Essentially, you're allowing your visual processing system to work in an optimal way as long as everything is in line. I know what is inside that if statement because it's indented. And as long as I have a nice clean line where all of these, I have a clean line for, let's say, this right here, as long as that's vertical, straight up and down, I can process things intelligently. If it starts getting jaggedy and it wobbles all the way around, there's no way for me to properly see how everything flows. And so what we're trying to do is don't fight your visual processing system, and don't fight your Visual Studio or whatever integrated development environment you're using. If I'm if I push, if I make an if statement and press return, it will automatically indent for me. Don't try and fight it. Don't try and redesign it. And if it's not formatting the correct way, that's a dead giveaway that you have some kind of syntax error that you have to fix. For example, I forgot to put a semicolon there and I pressed enter, or I forgot to put a curly brace in here and I pressed enter. It's going to look weird. It's not going to be in the right format, and that's the obvious giveaway, that the red flag, if you will, that you need to stop, fix your code rather than trying to force the IDE to do something different. If it doesn't automatically do it for you, then probably your code is wrong. Indentations used to have to be done by hand, and it was a major pain because things wouldn't be perfectly aligned for you. Nowadays, it's actually quite easy to make sure everything is indented. And if it's not properly indented, every other programmer that looks at your code will get very angry with you. It is very much like doing an English essay without using punctuation, or doing an English essay without using any kind of paragraphs. Indentations are how we view the world. It's how we parse things. That's how I can read your code as quickly as I do, because I'm using that indentation for how everything works. And if you don't do that, you're going to make everyone else using your code, including yourself 2 months later, they'll be fighting against what you did. All right. So Here's our level 0 on the far side. Here's our level 1 for our if statements. And here's our level 2 in our body. It's 2 tabs in. Each one of these is 1 tab over just to make sure that you can cleanly see what is indented from what. Okay. For comments themselves, for a single line we have a double slash. For a block of comments, we have slash star star slash. And both of them work relatively well. If I want a giant block of comments, the star slash slash star slash star star slash works remarkably well. For a single line, double slash works well. It's the comments are absolutely critical, especially at the top of my file. If I'm talking, let's say, the CD.go's code base was, I think it was at least 1 million lines of code. The video game I did back in 2001, I guess, was 500,000 lines of code. If you're looking at 500,000 lines of code distributed over, let's say, 200 different files, you need a really easy way to understand what the heck that file is for. It's a needle in a haystack to find out where a bug might be. And so a comment at the top of your file, especially your header file, but a comment at the top of your file, at the head or the top of your file, allows you to figure out what the author of this code actually was trying to do there, and whether it's worthwhile to look into that function more or to figure out what the heck's going on. It gives you the context. So it would be like if I jumped into a math proof but didn't tell you what I was trying to prove. There was no English explanation at the beginning. I just jump into some kind of math proof with a whole bunch of Greek letters everywhere. You wouldn't know what was going on. What I want is this comment allows other people to read my code and say, "Oh, this person was trying to do this," or "This function, this file is for reading in files," for example. It's a nice, clean, very hopefully succinct comment about what this thing is supposed to do. And ideally, for a particular file, I want things. So for any given function, I want a header. So each function is this. And at the top of my file, I want a file header, which would be something like who wrote it, what the name of the file should be, just in case you change it. That's questionable. But who wrote it, when it was written, so you know how out of date this thing is, what is it for, maybe some kind of summary of what this thing is for. Every single company will have a different format, will have a different style for what the comment should say and what you need to have, but some kind of overarching comment for each file and for each function is extremely useful, just to help you understand what's going on. Because you can look at the code all day, but it doesn't. Just a quick summary of what goes in, what goes out, what this function is for is extremely useful. So hopefully I have another example of there you go. So here's a good function comment. Here's the name of the function, count big pics, what's its purpose, what's going in. I have an image, number of columns, and a threshold for it for the number of pixels, what it returns, what are the possible ranges of values I can do, what it returns, what kind of data it's returning. Of course, if you change the code, you need to change the comment, and that's where things can get a little wonky. Is that I know have problems with this as well. Not changing your comment after you change your code. It's actually led to all sorts of problems in various assignments that I've made. But that's ideally when you make the change to the code, you have to make a change to the comment to make sure they're matched. All right. So let's see what we have here. So with a function header, we have a little block of text at the top to let people understand what's going on. And if in my function itself, I can make particular comments with a double slash. If there's only one function in a file, this doesn't come up. But if there's only one function in the file, you can merge the header, the file header, and the function header together. But I don't think I've ever had one function in an entire file. The other thing to note is if I want to block comment a bunch of stuff out, this thing will only, I cannot have nested block comments. So I'm going to move the slide, sorry. I cannot have nested block comments. So right here, if I put this block comment somewhere in my code, I cannot put a block comment around this whole thing, or comment code out code that I'm just testing things for. I can't make that kind of like remove a block of comment. Like I did this last time with the file input. I just blocked out an entire chunk of code. Well, because of if I use a block comment at the top, because I can't do this nesting, some people actually prefer to use double slashes for my header. It's a personal taste thing. There are ways of, for the double slash, there are ways of making all like 20 lines of text, for example, all have this double slash in front of it. So it depends on personal philosophy, but the big take home is at the head of my function, the top of my function, I should always have some kind of comment to say what this thing is for. You don't need to do this for the exam per se, but you would need to do it if you're writing something in industry. All right. So, and if I have an inline comment, as in I'm doing a bunch of coding, I have some kind of weird mathematical formulation, I'm not sure people will understand what I'm trying to do here, then I want to put some kind of comment saying what it's doing, what it's trying to do. So when we were doing that comma delimiter code, maybe I want to put some comments saying why I am moving it one step past the comma. So uh, that would, for tricky code, if it's not obvious, I want to put an inline code comment. So we do not want to comment when things are obvious, and we don't put comments on the same line normally. So in case you're wondering, I normally would put this, in case you're wondering, up here, but really this sets x to 5. Well, I could read that. You don't need to explain that. It's literally on that line. It's actually taking you more characters to explain it in English than it is to write that the expression. This is a stupid comment. It should be gone. We have doubled the value of x. Well, of course you've doubled the value of x. It's right there. And then we've saved it to y. Okay. And saved it to y. Notice the actual issue why I said put your comment on top of your line. Because what if my screen ends about here? If my screen ends about here, I'm going to have a word wrap. My comment's going to go on the next line, and it's going to look weird. It's going to be this of x and just floating on the line below it. It'll be green, but I won't know why it's green, and I won't know what the heck is going on. What I really want is clean lines with a double slash saying, hey, this is the comment, and it never goes to the new line. I manually go to the new line each and every time. So I want to make sure I have an absolute hard width, no more than about 80 characters. If you want, just for various screen sizes, 80 characters is a good solid number, because some people may have the fonts larger than you might expect. You don't want to just do it to your screen. You want it to make sure that it doesn't line wrap almost on anyone's screen. So, and this is another useless thing. Compute the average by dividing the sum of the number value. The variable's called average. You take two numbers and you divide it by 2. I'm hoping that's a pretty obvious thing what it's doing. As obvious as the comment is itself, right? Obvious comments are useless and they don't actually help. Your comments, if you're making a comment, it better be of some use, but you definitely want to put comments in to explain things. You are trying to make it your life easier. 3 months from now, if you look at your code, will you understand what it's doing? That's sort of the golden rule here, or a good heuristic to be using at least. If 3 months later, if I'm looking at this code, would I understand it? If not, I need a comment. If so, leave it alone. Because invariably 3 months later, you're going to look at your own code because there's going to be some bug, and you will honestly not know what the heck you are doing or what the heck that code is supposed to do. It's completely slipped out of your mind. I've done it. Every single programmer I know has been in this situation where they look at their old code months later and go, "What was I thinking? What the heck does this even do?" That's why we have comments. It's for your own sake. All right. So using appropriate variable names is one of our other metrics. So X, Y, and Z, terrible variable names. Unless you're talking about coordinates in space, like three-dimensional space, X, Y, and Z are not the variable names for you, right? So I want some other value better than this. So this is, we need some other, even something as crappy as val1 would be better. It's some value, and it's the number 1. All right, that's still better than X, Y, and Z, because X, Y, and Z suggests that it's actually a coordinate in space, which it's not. Val 1, Val 2, Val 3 might be okay. I don't have to do this, so AVG. I want it short and sweet. I want it to be obvious what it is, but not have to write a whole bunch of stuff. Because I'm lazy, you can be lazy too. We're trying to write the minimum amount of stuff while still being obvious. So, my text, it is your text, right? It could be a text, that would be also perfectly fine. But the a, again, this is Hungarian notation. That's my personal approach to doing things. You do not have to follow this, but this is for an array, this is for a pointer, and it makes it a bit more obvious what the heck this is, what these variables are for, what kind of variable it is. But it should be pretty obvious what I have. So it's instead of maybe it's not val, maybe is, you know, num1. Well, that's a number, clearly. Char1. Oh, that's character, obviously, right? Maybe you can use that. You're trying to make it as obvious without having to write any more than you have to. So we never reuse our variables. If you have A, B, and C as your variable, so let me tell you a little story. I had a PhD student in computer science apply for a job when I was doing my master's degree. He applied for the job and he was very proud of how good his code was, I think. Anyways, he said he never made a bug in his life, which I don't believe at all. And I got to look over his code later on. He had variables A, B, C, and D in his variables as number as integers that he reused for four different things in one function, and the one function was about 400 lines of code later. I swore we would never hire this person at all. We didn't, because I couldn't trust this person's code at all. If you're going to reuse a variable, how do you know it's not going to change? We can make other variables. Just it doesn't cost you anything. It's not like we're back in the 1960s and that variable took up a whole chunk of memory, way too much memory. Each variable is, let's say it's 4 bytes of data. That is nothing if when you're having, you have 8 gigs of RAM. 4 bytes is not going to even, you're not even going to notice that thing. We want our variables to be descriptive, and we want to make sure that we know what it's useful for. And if you're reusing your variables, you don't know how it's being used now. Um, we also try and avoid global variables as a general rule. I'm going to add this to, so I just forgot about this one. We haven't even hit global variables, but in this class, but just in case it comes up, a global variable is just a variable outside of any function. It's just sitting around, and everybody has access to it. Every single function can modify it, and all sorts of wackiness can ensue as a result. So global variables, not global constants, but global variables are absolutely no-nos if you can avoid them. They're not There's very few times I've ever hit where I've said, okay, I need a global variable here. We don't reuse our variables either, and the name should be short and sweet, like AVG, PTR, whatever the case, IDX, right? Something that's obvious what it does, but yet I'm trying to write as little as I possibly can. X does not tell me what it is. This is what's called camel case because it looks like camel's humps, right? Every single new word I capitalize it. So the V, the N, and the Z or Z are all capitalized. And so I know this val not zero. That's fairly easy to read versus this val not zero, right? I have no idea where the next word is. Um, so I'm trying to think of Chris Jocelyn, the director of the department, said, like, I'm trying to think of F I T. What was it again? He It was CS Fit. No, Faculty of Information Technology. So Faculty of Information Technology, and I'm just trying to remember what the name of this was. Uh, no, it can't be Faculty of Information Technology. There was a recent URL he was trying to pass around as a suggestion for what the name we could use for Zoom was. And when he came up with this variable or this name, 3 or 4 of the faculty members looked at it. overlooked one character in the middle and read it wrong and said, "What fit? What we're not fit. Like, what are we going to work out or something like that?" It was one of those weird cases where everyone read it wrong because there was no camel casing, there was no up and downs. If I have this val is not okay. This val, I'm just trying to see if I can make a particular word in here that's gonna break. Um, I can't think of a good example here. So if I have this no camel casing, what I might have is this word and this word might actually be one. You might accidentally parse it wrong and combine letters together. So this val not zero is not a great example. Um, I'm trying to see another one. Variable. Okay. Uh, Here you go. Variable is able to divide versus no camel case variable to div. Now you probably can't read it very well, but that looks like variable to divide, not variable is able to divide, right? They're two different contexts, and there are cases where you'll hit where it will not be obvious how to parse this, or I'll parse it wrong, and I'll be constantly just having to reread it. Camel case allows me to know what is a new word each time. I'm allowed abbreviations, by the way, as long as they are sort of consistent and they make sense and everyone will know what you're trying to get across. And we have naming conventions. IJK is for loops. X, Y, and Z are for coordinates in space. IDX is for a particular index. Right? There are certain things that you can get used to seeing over and over again. Don't try and reinvent the wheel. If I have a for loop, I don't call it count. I don't call it IDX or something like that. I call it IJK. All right. And then finally, we have the keep it simple, stupid principle. This is not KISS, I want to rock and roll all night, party every day. This is keep it simple, stupid, as in everybody is stupid. That is not a statement to you or anyone else in the general population. It is everybody. We all overthink things. And this principle it applies for user interface design, it applies to code, it applies to almost everything that you do. Every time we get all cutesy and we try and do something fancy pants, it ends up biting us. If you can make it as simple as possible, that's the ideal. Any great designer, that's one of the paramount ideas for great design, right? That you keep it as simple as possible and no simpler, because otherwise, if you add complexity, you're gonna hurt yourself. So here would be an example of a terrible, terrible interface. So I'm going to make a variable IDX outside of my for loop. Why? Because it's going to make it more complicated. I'm not going to use IJK. I'm just going to use IDX because I want to reinvent the wheel because, fun. I'm going to, instead of starting at 0, I'm going to start at 1. And then I'm going to go but up to and including array size. And I'm also going to throw another condition just to make sure, I made this index up here beforehand. So for all I know, somebody set the value to -1. So I also need another test to see IDX is greater than or equal to 0. And then I'm going to increment IDX. Oh, and then I'm going to have a print statement, then another print statement, then another print statement here. Oh, and let's make it even more complicated. Because my index starts at 1 and goes up to and including array size, now I need the index is actually got to be decremented by 1, right? That is terrible. What I want is a simple for loop with one stupid expression in there. It's going from 0 to and but not including array size, and I have one statement in each side, right? This is way easier to read. This right here, this second function right here, is way easier to read than the one above. If I can make it simpler, why not? If I make things more complicated than they need to be, I'm not going to be able to understand it 2 months later. So this is the keep it simple, stupid principle. If you try and make things overly convoluted, overly complex, it ends up no one understands it, and maybe you don't even understand it later. Um, we don't get to play with this very often, but making the code more efficient, we'll see some basic examples, but this is a fundamental principle in computer science that there are ways of approaching the problem of solving something computationally that are more efficient than others. So let's take, for example, this top for loop. I have a for loop where I'm going to take each element, like let's say I have this string of 500 characters long. So it's a fairly long string. And for each one of these characters, I am going to, let's say, print out each one of these characters, or whatever the case is. Or maybe I'm just checking to see if there's a comma here. What will this end up doing? This is, I start at 0, and each time through the loop, I have to calculate this. I have to figure out what the length of this string is. In order to figure out the length of that string, I have to walk down the entire string and count things. We looked at how string length would be implemented. I would need to do 500 steps. For each character, I need to go down my string until I get to the null terminating, or the null character at the end. I'm going to keep on. I have to walk down my entire string until I get to that null character. So I have to do 500 comparisons every single time I call strlen. And every time through this loop, I do those 500 comparisons. So I'm doing 500 comparisons 500 times, right? It's 0 to 500. So this is 500 comparisons 500 times. This is 250,000 comparisons here. I have to do 250,000 comparisons if I do it up here. Or I can do this one time, 500 comparisons, and then do another 500 comparisons. Actually, this should be a grand total of 1,000 comparisons. But it's still a noticeable difference. This is 250 times worse than the original. As numbers get bigger, as my code gets more complex, as I get more pixels I'm pushing on the screen, more the frame rate goes higher, the resolution gets bigger. Whatever the case is, the bigger the numbers end up getting, the worse this thing is going to perform. That's what efficient code is all about. It is not just making it readable, but making it efficient. And you'll actually notice that change in efficiency. We'll look at that in 2400 as well, that there are some ways of searching through an array, what's called a linear search, which will take n steps, right? The size of my array is n, it will take n steps to find something. If it's a sorted array, I can do it in log base 2 of n steps, much, much smaller, right? There are things that are sorting algorithms that you can actually get a stopwatch, and you can easily see it even with numbers of about 10,000 elements. You'll see it on a stop. You'll see it actually timed, where one function will take, let's say, a second or less than a second. The other one may take 5 seconds. It is quite alarming how much of a difference efficient code makes. And this is literally how every single technical interview I've ever done ended. Every single time I had to use a whiteboard and they said, hey, give me, make an algorithm that does this or that. At the end, the question they always asked was, what is the complexity of this algorithm? What's the speed of this algorithm? This is something that you would learn if you did a full computer science degree. We're not going to go, headlong into this, but the expectation is what makes efficient code and what is not efficient code. And if I see something like I have to do 250,000 comparisons instead of 1,000, that's not efficient code. So that's what we're trying to aim for, efficiency. We also want to minimize the number of side effects and guarantees. So like, for example, if I say you can give me a number between 0 and 255, if this thing takes in an integer, you can expect the user calling your function to give you things other than 0 to 255. They could give you -1. They can give you all sorts of numbers. So we want to minimize things that have either side effects, as in it's changing some random variable somewhere else, or special cases, as in like, oh, but on a Tuesday you can't call this function because then it blows up. Right? If you're saying you can pass in an integer, make sure it can handle an integer. That's this input guarantee as well, right? If I'm taking an absolute value function, the better function would take in any number, not just integers, but doubles, for example, and it will return a positive double. And rather than saying it returns some kind of double, we can say, no, we're guaranteeing that it's going to be a positive double. If we can make in our comments, if we can make claims about what possible input I can take in and what possible output it can spit out, I want as general of an input as I can, ideally, and I want as precise of an output as I possibly can give. And that gives me a better, it allows people to use my code in a more efficient way, and it means I have a better function, right? That if this function can deal with any type of number, that's better than it only taking integers, or in many cases at least. If my number can only be between 0 and 255, and I don't want to accept anything else, I don't take in an integer. I take a character instead, right? I want to try and make sure that I don't have these little weird gotchas along the way. And I want to be able to say that this function can handle sort of a maximum amount of stuff, and I make certain constraints or certain claims about what the return value is. All right. We also absolutely avoid hard coding whenever possible. Sometimes there's no avoiding it, but those points are few and far between, right? So here would be a really terrible version of malloc, right? I want to make an array of 20 integers. Well, if I put in the number 80, that's terrible. Why? Because you need to know how big an integer is, and you also hard coded the value 20. This is slightly, and you also have to know why it's 80, right? This is slightly better. At least you see, hey, that 4 is for the number of bytes of an integer, and this thing here is how big this array is supposed to be. And by the way, this can get pre-computed, so it's not like you're even calculating this on the fly. This can be done by the compiler, right? At least you know what this is made up of. It's 20 integers. But even then, that's pretty terrible. So in case the size of an integer changes, I want to use size of. I don't want to hard code a value 4. Okay, and the array is size 20. And I can still do one better than that. I can use a constant instead. Instead of just hard coding in the value 20, what if I want to make my array size 50 instead? Well, instead of having 20s all throughout my code all over the place, I have it defined one place, and I just change that one place is defined, and it should all work. So if we hard code particular values, sometimes if I hard coded pi in a bunch of different places, well, what if I had 3.14 in one place, and then I had 3.141 in another place, and 3.1415, whatever the heck pi is, right, in another place? What if I need to change precision of pi? I don't want to have to change this in a bunch of places, and I don't want it being inconsistent. So if you see yourself putting in the same number multiple times, put in a constant. Define it once, define it right, and then put in a constant. And this is using preprocessor instructions. I can define what bit 1400 the bit 1400 name is. It's the string bit 1400. Or I could make a constant integer, for example, and put a value. Both are ways of doing it so that you only do it once. This is a pre compilation instruction, right? This define, I'm defining what my pi is, and then 3.14 will get stuffed in everywhere. Every time that you see the word my pi in your code, it would actually be inserting 3.14 in that part of your code. Or I could define a constant variable and use that. Both would be fine. They're both better than hard coding in the value 20 or hard coding in the value for pi. So I accidentally said this in one of the labs, and people were actually trying to figure this out. I mean, go ahead if you want to try, but don't expect me to try and understand what the hell this does. This is legitimate code. This would actually compile. If you don't actually format it, it will actually try and compile this, and it will actually compile it successfully. I have no idea what the heck this function is doing. Or this is actually just the main method, but I have no idea what's going on here or what it actually does. I've stared at this snippet of code for a long while. You can make completely incomprehensible code anytime. It is easy to make something that's impossible to read. It is very, very difficult to make things that are very clean and precise and concise. So, for example, look at my indentation. My if is in here, my ts is equal to seg2 blah 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 is out here, and I don't expect that. This is supposed to be inside this if statement, and I have no idea how it all works, right? That my curly brace is here, but what does that match up to? I have to count up, and I think it matches up to this one right here. So this curly brace is connected with this one. You could be spending hours trying to deduce where all of these things go. Once you've looked at enough code, it's really quick to be able to parse things. That's what we're trying to train you for. That's part of the reason we have so much practice. Okay, so let me talk about what A11 is going to be, and I still have to make A11 or at least polish it up for you guys. But what we're going to be doing is we're going to be doing a peer review. I'm going to post an ID or let me think of what the best way of doing this. Yeah, I think that's what we did last time around. I had a Google sheet with everyone's anonymous code in, links to all their code from that we're hosting for you guys. So we're not putting our names in A9, or if we are, the TAs are going to have to manually remove all your names. We'll have your ID, we'll have the person you're reviewing's ID, and so you will find the other person's ID in this list of all submissions for A9. You will then open their file and you will review it. You'll be trying to critique their code based off of the code quality. So you'll find 3 good points, 3 bad points, and you're supposed to be nice about it but thorough, and make suggestions on how they could improve their code. So you're not even having to write your own code in this case. You just have to review other people's code and determine if they did a very good job with the code formatting, the code quality. If their code is incomplete, and it's really incomplete, like partially incomplete, okay, fine. You can still review it. But if they didn't submit something, or they submitted something that is just a blank file, you'll have to just talk to us, and we'll pivot and change things. We'll just point you to somebody else that did the code and actually did the work. Because we want every single person to be able to review a legitimate submission and be able to give feedback on that submission. And one of the things I got from this last time around is students quickly learned if other students in the class were keeping up. So if you were struggling with the class and you see some really nice code somewhere else, you know you're struggling. And there are other students that were thinking I was writing them too hard, or I was being too mean, or whatever the case is, and they saw somebody else's submission and went, oh, that's why you're being so mean about this, because there's some people that just are not, at least last term, we're not really keeping up. And this is telling you where you sit in the class and if you need to suddenly put in a Herculean effort to try and pass the exam. That's a nice side effect, at least. So I want to go over a quick code example, and this is when we're going to end our lecture after I do this code example. So let's have a look at this. Here is the actual code that we did last time with the CSV, but instead I screwed it up on purpose. So I want to look at what kind of horrible things are in this code and see if we can actually try and fix it. May not be able to, but well, let's try. This code will actually run, by the way. So in case you're wondering, let's compile it, and there you go. So it's doing what we expected it to last time. It's reading in the CSV file and outputting stuff. Great. So what am I missing? Well, first of all, I have a useless comment at the top. Include statements. Well, of course, there are include statements, so that's stupid. Okay. I might want to put something else, but what I really want is I would like some kind of file header should go here. I'm not going to write the whole thing while I'm live coding with you guys, but in case you're wondering, that's what should go there. My main method, I would like something about my main method. Main method, explain the function doing and what the purpose of the code is. All right, some kind of block comment in there. Normally what I'd have is input and output claims. So things like input colon blah, output colon blah, things like that, where I say what's going in, what's going out of my function, what the point of this function is. This is just intentionally being very vague, but I'm trying. So I could call file f. I don't like that idea. So p my file or p file. Let's call it p file. It's a pointer to a file. It's a bit better than f. F could be any number of other things. So, and I'm going to just, let's save it. I should find all sorts of problems in here. is there any other places I'm missing? The file close is here, and the printf statement. Huh, that's surprising. I'm surprised I didn't have a compile error in here. So let's have a look at, that's not it, it's F. I had two things named F, and it didn't compile, it didn't scream at me, despite the fact one was a file and the other one was an array. See, this is why we need proper names, so that you know what the heck went wrong. Because there's no way I would have been able, that would have been a really hard time trying to debug that thing. Okay, so first of all, I have this particular file that I'm reading in. Okay, I sort of, I don't really need a lot of explanation on this. I could say something like, in case people are not wondering, uh, if file opened correctly, read each field, each comma separated field. Please ignore any kind of spelling mistakes if I make any spelling mistakes. That number 100, I don't like that. So let's put in something here for that. So let's do constant int buff max line len, because I also know further down I hard coded the value 99 in here, one less than what I needed, and subtract 1. I have the maximum length of my line would be 100, and one of those is for the null terminating character at the end. Okay. Now, maybe you want a smaller name for this, right? Max line. Max line length seems to work. It's pretty descriptive. But if I change it to, let's say it didn't work and I changed it to 200, I don't need to do anything else. I don't need to change some other variable later. If I change it in one place, it changes everywhere. I would also like to point out number of characters. Is it actually anywhere else in my file? Nope. I don't need that parameter at all. It's just there cluttering things up. It's not being used at all. All right. I got a bunch of random white space. Why? Because, well, because I wanted to show you what ugly random white space would look like. And let's clean that up as well. Okay, well, this is safety precaution things. I'm actually probably not using that variable at all, but let's, for the time being, leave it alone. But notice I don't want it at the end of the line, because if it happened to be too long, it would wrap. I don't want it continuing on the line, because let's see where my character is right here. We are at column or character 58 there. So here's 80. Now I have fairly big font size right now, but it's very easy to go beyond that. But you want a nice clean line of about 80 characters. You do not go any further than that. That's what we're trying to avoid, because if you go further than that, you're going to get wraparound issues. The text is going to wrap and it's going to look really weird. So let's try it out. All right, and if I go to print off something, or if I try in some other systems, well, first of all, I'm going to have to scroll, and if I try to print this, it's going to be on another line. It's being clipped over on this side here. It's just generally bad. We don't want any kind of line wrapping whatsoever, or any having to use a scroll bar at the bottom at all. So we should actually check to see why. Let's see what this is. Like character 70. There's something here that's actually making this abnormally wide. So anyways, let's keep going. So I have this. I have a particular character. This is going to be the start of my line. I'm going to call F-get-S, and I'm going to put all this file into this buffer. So the next line of text into this buffer. The maximum number of characters I'm going to read in is 99, because I have this extra character. Actually, the maximum length. Yeah, this is the number of characters I'm going to read in. I want to make sure I don't overrun things. So I'm being cautious and doing a -1. I have a pointer to the start of that buffer just to make sure, just in case fgetS does not work. So I check to see if fgetS actually gives me a line of text or if something bad happens. And then, okay, from there, oh crap. What is S? I have no idea anymore. Actually, I do know now, but it took me a second. What the heck is S actually trying to represent? Well, S in this case is, let's say, start IDX. It is the index where the start of my field is. Or I could say F start IDX for field start IDX. Right? I want something, and people are going to have different opinions on what makes a good variable name, that sort of thing. But I want to be clear that we do want to have some rhyme or reason. You want to think about your variable names before you just randomly put some number or some other character in there. All right, let's make sure that all works. Okay, end index value. Do I use this at all? Let's find out. Oh, actually, I got rid of it. Oh, it's almost like I did that on purpose. Let's get rid of that particular thing. I don't need technically that variable. I have another buffer. F is a pretty terrible name, so a field, let's say, and I want to keep on putting out F field. This is what I'm going to, so let me walk through what this code is actually supposed to do. I'm going to take up this entire line of code, this entire line of text. I'm going to walk character by character down this entire line of text. Every time I notice a comma, I am going to every single time I notice a comma, and I also want to make sure it starts at the right position. Okay, I'm going to start at position 0 each time. Okay, and so I'm walking down this line of text. Every time I find a comma in there, I know from the start index all the way to that comma is a field. And then I'm going to change the start index to be the next field, the character immediately afterwards. So if I find a comma, then I'm going to copy all of the characters, character by character. I'm going to copy from characters from a buffer to this new scratch buffer. Is essentially where I'm going to store just the one field that I'm dealing with at a time. A buffer has all the text. This is one particular field in there. And then afterwards, I'm going to, after I've done all of this, so I copied all those characters over to a field, and then I'm just going to print off that particular field. And then, oh, there we go, we got an email. And then afterwards, I'm going to change the start index to be the position immediately after the comma. So I'm going to I'm going to look at a chunk of text, and every time I find a comma, I'm going to move my starting position so that I start all over again. And then after all is said and done, I'm going to output this text one more time out to the screen, and then I'm done. Okay, so this is a weird view, and also notice it's hard to explain because that for loop sucks. Look at it. It starts at starting index and then it's going to go up to but not including the I. You could say it's good, but I don't like it. It's not following my normal pattern. I always start at 0. So we're going to go up to I, but are we sure what's I? Yeah. So maybe I want to make my life, it might be easier, it might be harder, depending on how I want to do the math. But I thought it was harder to do it this way. So, and oh, look at this horrendously inefficient thing. I am going to call string length on a buffer each and every time to get the length of this thing. What I could do instead is I want to have line len, and that is this thing. Also notice one of the reasons I needed to use this scratch buffer is because I couldn't modify the original buffer. If I did, the string length of a buffer would have changed, and then my for loop would have broken. So if I changed the what was in a buffer, I could change how string length works, and therefore I would change my for loop. That's actually one of the reasons I needed this extra buffer, this a field thing. Before we were just stomping on the comma. I couldn't do that anymore because I was using string length. But I'm going to keep on doing this approach, but there was another limitation of using string length every single time through my for loop, is if I change a buffer, string length may change on me, and I don't want that. I want to do that many characters no matter what. Okay, so I have this particular thing. So I might want to comment some kind of comment about store. I really shouldn't have these pop-ups in here. Store characters from f start index to the next comma in array a field. Then update f start index to be immediately after comma. And what character am I? Oh, I'm on a new. I want to put it on a new line because I'm at line 83. So there you go. And I might want to put a little bit of blank space in here. What else do I want? Well, there's this comma here. I actually don't like that idea. So let's put this char delimiter. Let's call it char delimit, and that's going to be equal to comma. Because if instead it's no longer using commas and it's going to be using tabs, or it's going to be something else, I can just do that, just in case. Now, the comma sort of makes sense here, but sometimes I don't want that, and so I could have done, using it explicitly stating what the delimiter was. All right, so I'm going to get the particular line. I am going to put everything into this field here for each one of those fields. And what else do I need? I'm going to start at, this thing is going to start at position, well, I don't want to start it here. So I want to have some variable field len is equal to, and I want to have I minus f start index and I want to start this at 0. I'm going to go up to, but not including this, j++, and then for each one of these things, I'm going to go at position j, and I'm going to have, so I want f start index, and that should do it. I find that's a bit easier. I have a for loop. It starts at 0, ends at field length, and I'm just doing a particular offset forward rather than trying to do subtraction. The particular field at the end, I want to make sure that this is, then I'll do this, field length, and that's going to be equal to 0. Well, actually, I don't want 0. I want the null character. They are the same thing, but it's not as clear what my code is doing unless I actually use this thing. It's still equal to 0, but I want to be very explicit that I'm putting in a character. It's not an accident. I don't think it's a number. I don't think it's a null. I'm putting in a character. I then output my field, and then I want to move the starting position, the index where I'm looking at, to one after the comma. Okay, this here is, I'm surprised that hasn't barfed on me. Let's have a look at why that hasn't barfed on me. Oh, that's not a field. It is, yeah, that's a field. Okay, so where's f defined? Oh, f is still our file, isn't it? No. Where the heck is this f, and why isn't it cursing at me? And I'm going to throw this out, a field, and that should do it. I also want to clean up this thing here. I'll leave that space there. I could, this is one of those places where I can do this. Something like for loop for each line. This is not the for loop for each line. I want to see what the heck this is doing. Oh, this is the if statement. If a line of text was read. All right, and for loop each field. Is that a for loop? Let's see what I have here. Yeah, it's a for loop. For loop over line of text. There you go. I'll put it on a new line to make some spacing. Compile that again. And let's have a look. It still works. Same as before. Hopefully the comments and the text themselves is actually going to look a bit better. I want to make sure I have my for loops. I want to make sure everything's indented correctly. So this is indented in the for loop, for example. I want to make sure that the variables make sense, that I can sort of figure out what all of this stuff is doing. I want to make sure that if there's a line of or a chunk of text that I don't know what's happening or I wasn't sure about it, I want to put a comment to make sure that other people will read it and understand what's going on. I can't see where the start of my main is, so why not like put a little, sometimes we put comments at the end to say what that's the end to, right? I just want to make this as obvious to anyone reading it as I possibly can, and that's what always the goal is. This is actually not the end of that, so what is this ending? This is the end of my if file. See, told you that it can be very confusing where these things are. And end of if file exists. All right, and here's my end of my main. I should actually return 0. All right, and then I compile again. Now, I'm not going to claim that this is perfect code by any stretch of the imagination. I'm just trying to play with how I could improve my code as I go along by adding comments where it's necessary, adding header, so adding some kind of comment to the top of my header of the top of my file, some header comment, so that people know what the point of this file is. So I might want to include proper variable names rather than F for everything. I will want to make sure that I don't have just random constants floating around here, but I use that I'll actually save it as a constant integer, for example, and use that instead. I'm trying to make it so that other people can use my code and that the complexity of the code doesn't wear me down. Because we've already looked at one quote from one of the inventors of C who said that as we all know, debugging is twice as hard as writing the code originally. So if you're as clever as possible when writing your code, how are you ever supposed to debug it? This is what we're talking about here. I want to make my code really obvious because later on, I'm going to have to debug it. Even if you don't have to do it in this course, you'll have to do it in other places. And so making your life easier for yourself and others by having a proper coding style is absolutely paramount. With that being said, I'm going to stop the video and I might do a review lecture afterwards so that we can go over topics, and I'll post a survey of what topics you want me to go over, and we'll go over a number of problems with a video before the final exam. All right, thanks everyone. Have a good day. Bye.